The vision of a simple, reliable and powerful generator for self-generated energy is getting closer and closer. Your many great ideas, and in some cases fully developed designs for key components, shared on Discord, in the comments and via email, are fantastic and are helping the project to progress quickly. The powerful thermoacoustic engine, made from self-printed components, and only a single commercially printed metal or ceramic heater, is taking shape more and more clearly. Many details are still uncertain, and the best solutions for the various requirements have yet to be found. In my latest videos, I have shared the details, blueprints and 3D models of the power core and the feedback loop. Now we will move on to the power extraction unit, which converts acoustic energy into mechanical and electrical energy. To generate enough energy during the winter and during periods without direct sunlight, a generator powered by self-produced biogas, for example, is a useful addition. Unlike complex and high-maintenance mechanical engines, the construction of the thermoacoustic engine requires almost no expensive machinery or specialized technology. The aim is to design the engine in a way that anyone with an affordable 3D printer can print the generator themselves. Only the heating unit and regenerator from metal or ceramic needs to be ordered from a 3D printing service. Even plans are already underway for own 3D printing of ceramics, which is relatively inexpensive, but requires a great deal of experience for the burning process. Thanks also to the 3D printing experts for their tremendous help. This video covers the power extraction unit. The power core and the feedback loop were discussed in detail in the previous videos, and links to download the blueprints and the 3D models were provided. The power extraction unit is a key part of a successful thermoacoustic engine, since the components responsible for converting acoustic energy into mechanical energy and then into electrical energy are the only moving mechanical parts. The quality and durability of the motor depends on them. A wide variety of methods can be used for this purpose. The power extraction unit should be as low friction, low wear and low maintenance as possible. It should also be compact and scalable in terms of performance. It must integrate well into the housing to handle the upcoming pressurization and, ideally, also be suitable for starting the engine. So far, I have experimented with a bidirectional impulse turbine, oscillating stepper motors, a slider crank mechanism, and various linear generators. The bidirectional impulse turbine is very elegant and low maintenance, but highly complex, and its aerodynamic design is challenging. Once the performance of the thermoacoustic engine has improved significantly, I would like to further develop it. At the moment, it would have to be very small, which is not efficient. The slider crank mechanism is a well-established solution, but the fixed stroke restricts the acoustic waves too much and is, overall, too unflexible for the constantly changing operating conditions of the prototypes. Oscillating electric motors driven by a balancing lever offer a practical way to use standard motors while also achieving balance. Overall, it works very well and is definitely a practical application worth further development. However, to apply this principle, the power output must be increased further, as the small stepper motors used so far have very low efficiency when performing only oscillating motion. Linear generators make perfect use of purely linear oscillation, but they are complicated and complex. Both of my prototypes work well, but they are still underpowered. I have gained a lot of experience with them and would like to build on that next. I'm not sure whether I should continue developing the linear generator with moving coils, which is more powerful but also more complex. Using just a single coil and a single pair of magnets, phase cancellation can be avoided and the cable routing could be optimized using the guide rails with carbon brushes. Right at the moment, I think the principle of reluctance is very interesting. It could be a very simple and elegant alternative. To do this, I still need to run extensive simulations using FEMM to determine whether this approach can also keep up in terms of performance. At the moment, I am conducting experiments with various plastic pistons, which, due to their lower mass, not only cause less imbalance, but also deliver a significant boost in performance at frequencies that are sometimes twice as high. Additional tests involving energy recovery through spring-mounted piston end stops further improve performance. Further considerations for simplification and improvement include new ideas for balancing the system, such as using two power pistons in opposite direction that are rotated by 90 degrees, and employing a membrane or diaphragm instead of a piston. More details in the next video. Your feedback on Discord, in the comments, or via email is fantastic, and your ideas on how to simplify and improve the Thermoacoustic Stirling engine are helping the project move forward quickly. Thanks to your help, all components, except for the hot section around the heater, can now be built using 3D printing or readily available standard parts. That is why intensive development work is now underway on a printed heater made of metal or ceramic. It might even be possible to print and burn ceramic parts yourself using affordable means. Thanks also to the 3D printing experts for their wonderful help. Also, there is more on this in the next video. Which power extraction unit do you think holds the most promise for further development, especially in light of the upcoming pressurization? Right now, I'm favoring the idea of a reluctance linear generator, possibly in combinations with a membrane or diaphragm. As always, I'm really looking forward to your feedback, ideas and suggestions in the comments and on Discord. If you would like to support the videos and the project even further, you will find lots more exclusive content, 3D models, drawings and files in the members area and on Patreon. Thanks for watching.